Hello, we got the longest substring without repeating characters. This is a pretty popular one, and the objective is to find the longest substring without repeating characters. Surprisingly. Okay, and ABC is the longest substring with not repeating characters. If we want to add the A, then there's a repeating character here. With that example, there's only B, and with that example, we can go further and we can find this W key E. Okay, and the the string is consisting of English letter, digits, symbols, and spaces, and there are 5,000 of them. So that's a pretty big number. We need to do it linearly in a linear fraction linear time complexity. So we can restrict the area of our container by introducing our ASCII table from the space 32 to the last one. So this is English characters and special symbols to the 128. So this is the 96 characters. Okay, let's go with the with example. Okay, so we got the index I, and this index I is going to reflect the index I is equal to 0. So there going to be a 0. Now we're going to increment the index I to 1, and this is B, so they're going to be a B. And now we're going to increment that to 2, and the 2 is equal to I, but there's already something within the I element, and our last index, this is equal to 0, and this is equal to 0. So our last index is equal to 0, and this is equal to 2 right now. So our max is equal to 2 minus 0, which is 2 right now. And our last is going to be addition. Is going to be added from our current element, like 0 plus 1. So they're going to be a 1. Okay, so this is 5 index, and now we're going to change that to 2. And now we're going to iterate further. So this is I is equal to 3. So this is a B, and B, there's a 1 within the B. So the last index is equal to 1, and current index is equal to 3. So the characters without substring without repeating characters is equal to 2, and there is no change. So we're going to increment that one to leave it to 2, increment the last one to 2, to 2. That's 1 plus 0 plus 1, and place it to the current index of I. Now we're going to increment the index, and this is 4, and we're going further. This is A. Okay, and as you can see, there is still a here, right here. I'm going to go with the same with the same pattern. So let's go. So there is a 2 still. Last it will be equal to 3. This one will be equal to 4, and the index will go further. Okay, so we got A, B, and 5. Now there is a B. There is already a B here, so we need to go with the same pattern. So there's 2 is still handled by 5 minus 3 is equal to 2. And 3 is going to go from here to 5. 3 is going to also be removed from here to 4, because 3 plus 1 is 4. And now we're going to increment that one to 6. Okay, and now let's go further. Now it's C is equal to 6, so C is going to be 6 here. And there nothing is happening because this is nothing is happening. So we're going further because that was an empty field in the array. And now we're going to D, and D is also empty. So there's going to be a 7 as this is 7. Okay, so that was empty. We're going further, and now it's 8, and 8 is A. and a is equal to 4, so there was something, so we need to subtract 8 minus 4, that's 4 max length. Okay, we need to also place the last element, this 4 plus 1 here, that's 5. Okay, and now we're going to iterate further with our example. So 9, A, B, C, D, A, that's an A here, and now we're going to go with the with another A and another. I just forgot that that's supposed to be 8, and now we're going to go with the another 8, so that's 9. We have an 8 here, and now we're going to remove that one from that one. There is a 4, there is still a max, but now we're going to replace it with the 9, and we're outside of the array, so there's nothing more we can do, and this is the max. Okay, so let's code it, and we need to initialize the indexes table, which is equal to a and 96. Initialize it to the elements of reflecting that there is no element, so -1, let's say, and now initializing some variables that will be handled. So first of all, the last count, this is then an index, so this is an index of the last summing, and there's going to be a max which is equal to 0. And now let's loop through this array. Okay, and if let's initialize the C, so we got the clear vision of what character do we have right now, and don't repeat ourselves. That's gonna be I minus and space. Space is our lowest element in the array, because the space is the lowest ASCII, has the lowest ASCII value from the English letters, which is allowed in this exercise. So the space going to be reflecting the 0th element here. Okay, so we got the space, and if indexes with the C is not equal to 1, then -1, which if it's not 0, then we're going to include the max with the max and our current index minus last count, which we have. Okay, and the last count is equal to that max of last count and our indexes of C plus 1. So we're double checking if we're now going backward, because there's a possibility that we're gonna encounter the character that has had the lower value in the current position. So we want to keep track of the biggest value that we're like lowering and summing upon. Okay, so now we're going to go with the indexes. In other cases, indexes of C is equal to I. Okay, now we're going to return the max. That max, we need to also keep track of the last occurrence of the non-repeating characters. So when we went through this loop and the last element there's a longest substring, then we need to handle that. So that max, and there's going to be as that length minus last count, and that's going to be it. And that's not it, because there's a semicolon here, and yeah, and that's pretty much it. It's pretty darn fast. So yeah, thank you. If you learned something, that's pretty good algorithm. Like and subscribe. Thank you.